Hello and welcome back to Calculus2. This is the part one of partial fraction decomposition, integration by partial fraction decomposition. We're only going to discuss the process of partial fraction decomposition, which is actually pre-calculus, and then we're going to add integration on top of it. We're going to start in algebra all the way back, right? Make the way to calculus. So first off, I want to see what happens if I am to multiply x plus 3 times, let's say, x minus 5. Oh, sorry. No. 1 over x plus 3, let's say, plus 2 over x minus 5. So, what do I get when I add this? Now, this is your elementary algebra, algebra 1. You are supposed to find common denominator, and you are supposed to cross multiply for numerators and then add like terms. So, to solve this problem, I have to multiply left side by x minus 5 and multiply the right side by x plus 3. So now, what I get is the common denominator of x plus 3, x minus 5. And the numerators are x minus 5, when I cross multiply, plus 2x plus 6. And the answer here that we get, I should have done this, I need to be in one line better. So we have x plus 3, x minus 5, and then x minus 5 plus 2x plus 6 for the total of, we still have x plus 3, we can FOIL it, whatever, x squared minus 2x minus 15, and then we have 3x plus 1. So, we use basic algebra to now put the red arrow this way and say algebra. What I did is I took two rational functions and I added those two rational functions, had to find common denominator and all that, to get a single rational function on the other end. Partial fraction decomposition is going to be a method that is going to bring you back. So this is partial fraction. Now, just by show of hands, how many of you are going to differential equations eventually? This lecture, okay? When you do inverse Laplace transforms in chapter 4, this stuff. Yeah, so, and integration by parts, and some other thing. Calc2 is like a 70% prerequisite for that class. So, you really need to know this course well for DiffyQ as a prereq. And one of the key lectures for chapter 4 is this one. And then you have Laplace transform and inverse Laplace transform, both chapter 4. Laplace transform is integration by parts. Inverse Laplace transform is partial fraction decomposition. So you gotta know these things. All right. So clearly we did algebra to obtain the single rational function at the end. Partial fraction decomposition is going to take this and break it apart. That's the goal of partial fraction decomposition. So let's do it. 3x plus 1 over x squared minus 2x minus 15. Well, you have to factor denominator because you have to have factors in denominator that you will break apart. So this becomes 3x plus 1 over, and then when you factor this, we have x minus x plus 3, x minus 5 when you factor it. Now, you have to memorize 4 situations so you can set up partial fraction decomposition. I can't help you there other than write them down. You either memorize this stuff or walk away. There is nothing, you can't make this up. So here are the 4 setups. You will have, usually I put blah over x minus c. This is a linear term. And the setup for that is going to be a over x minus c. So you see those here. So that actually works for our problem. Then you have something over x minus c squared. And that will be set up as a over x minus c plus b over x minus c squared. That's a repeated linear term. Then we have set up for quadratic. If you have ax squared plus bx plus c, that will be set up as ax plus b over the same ax squared plus bx plus c. So sometimes you are not able to factor quadratic anymore, right? Then you have to use this. And the final one is blah over repeated. So ax squared plus bx plus c, everything squared, is going to have the same form like up there. We have ax plus b divided by ax squared plus bx plus c plus cx plus b over ax squared plus bx plus c squared. If you look at these formulas, there are a lot of things that you can catch up with and to memorize. Look at this. When you have a linear term in denominator, x minus 3x plus 5, or just x, maybe you should also make a little note over here, x minus 2, x plus 5, single x, they all belong to this. Note that it's just a constant over that. When you have x squared, you have a linear ax plus b. So it's always 1 power less in the numerator. So linear in the bottom will prog constants on top. Quadratic on the bottom will prog linears in the top. Anytime you have a repeated, you have 2 of them. So it's very structured, right? It's very easy to memorize this. And you have to memorize it. Otherwise, you're just going to stare at the problem, because you won't be able to set it up. You must memorize this. So now, what do I have? I have 3x plus 1. Now, that's the blah part. 3x plus 1 over x plus 3x minus 5. What is the setup here? The setup is I have 2 linears, so a over x plus 3 plus b over x minus 5. So now I need to make sure, I have to actually do this, make it a little bit smaller, but because you need to see everything. This problem here is 2 first problems. Are we agreed on that? Because this one is repeated, square. I don't have any of them squared, right? So these 2 are different. Now I'm using A for the first one, and then I have to use a different letter for the next one, right? So I use B. And we'll do more cases, but I need you to know that this is rule 1, rule 1. So both of these are rule 1. Rule 1 and rule 1. So label these maybe 1, 2, 3, 4, or rule 1, 2, 3, 4, whatever. So our setup for this particular problem was 2 rule 1s. And now I have this expression. What do I have? I just have to find what A and B are, right? So, well, the only thing I can do is to add the right-hand side using algebra, and then I'll compare left and right. and find out what a and b are. So multiply x minus 5 on this side and x plus 3 on this side. I still have my 3x plus 1 on the left, x plus 3x minus 5, not touching that. On the right hand side, common denominator, x plus 3x minus 5, great, right? What do I have on top? ax minus 5a plus bx plus 3b. And this is where you realize denominators are the same, so numerators must be the same, right? So when denominators cancel, what you get is 3x plus 1 is equal to ax minus 5a plus bx plus 3b. So this is it. You have to solve for a and b and get what they are as numbers from this one line somehow. Well, linear algebra works in the back, and linear algebra works in the back, and we have 3x plus 1. So now what I'm going to do is I'm going to put all of the terms that have x's on one pile, and all of the terms that are constant on another pile. So my red equation is 3x, well, there is a better way. You factor out x, but we'll deal with that. So 3x is equal to ax plus bx, and the blue equation is 1 equals negative 5a plus 3b. That's it. So you notice that you can cancel x in a top equation, right? So here we go. The red equation is now a plus b equals to 3, and the blue equation is negative 5a plus 3b equals to 1. I hope you can solve this, right? Whatever way you want. No one cares which way you solve this, whether it's substitution method or elimination method, or you throw bones into the whatever and you look at the outcome, right? Whatever way you know, whatever witchcraft you can perform, do it. Just get what a and b are. So what should we do here? We can do, I don't know, times 5. That will give us 5a plus 5b is equal to 15. Negative 5a plus 3b equals to 1. When you add these equations, a dies, right? Yes. And we have 8b is equal to 16. From there, b equals to 2. And if b is equal to 2, looking at the first equation where the 5 is, a must be 1. So now we go in our substitution over here, and we just plug in a is 1. So that's going to be 1 over x plus 3, plus b is 2 over x minus 5. And now, when we scroll all the way up, that's exactly where we started, right? So the process for decomposition is not as easy and trivial as algebra process to kind of right, put it on a pile. So addition process is going to get us common denominator and all of that stuff and get us here. And the partial decomposition, we have a lot of stuff that we have to do to undo this. Now, why are we doing this stuff? If you think about it, if you have an integral over here, dx, there is literally nothing you can do. It's not U sub, it's not trig sub, it's nothing. You can't do anything there, right? But after a partial fraction decomposition, if you have an integral here, dx, these are two ln answers, right? Without thinking, it's ln absolute x plus 3 plus 2 ln x minus absolute x minus 5 plus c. So again, it's a method that is going to make the problem possible to be solved. So we will focus on integration later. Today is mostly about setting these up and then calculating A and B. So the amount of variables that you are going to have, A, B, C, D, and so on, will depend solely on what denominator you have and how many factors that are squared and so on you're going to have. So that's the number of variables. The value of the variables obviously depends on both numerator and denominator. So as a practice, if I just have, let's say, x squared, well, let's go simple first. x minus 3 squared, for instance, I see a linear term and I see a repeated linear term. So for the linear term of x, I have a over x. For the repeated linear term, I have b over x minus 3 plus c over x minus 3 squared. Those are our setup, right? And as you can see, they're all constants because they're all linear here. Don't worry about the square. Square says repeated, so you have to do 2 for that one. So this one is single, and for the single one, I just get a over x. That's think of it as x minus 0 or x plus 0, right? So then it will look like this. So x belongs to linear terms, and linears are always constant over whatever is denominator. So now I have a over x there to set up, and over here I have x minus 3, but it's squared, so I have x minus 3 and x minus 3 squared. They're both linears, so b and c. Now, if you look at my formulas, these guys are a and b, right, in my formula. But a is already used up, so I have to move with next letters. So if I am to, instead of blah, if I am to put any other value, well, I mean any expression there, then I would be able to solve this problem, and I would have 3 by 3 system on the bottom. So the size of the system you're solving at the end depends solely on what's in the denominator, right? The amount of variables. So do you really want to see a linear term and a repeated quadratic? That's 5 variables right off the bat. Your system on the bottom is 5 equations and 5 unknowns. Now, for that, you can use matrix, right? If you have a TI-83 calculator, right, or 84, whatever, that can do matrix and you can solve quickly. I know you can't use it on the exam, but no reasonable instructor will give you, unless you're Rutgers. They have no calculator, so it's expected to do 5 by 5 like this. Right? Oh, how many people are screaming, I should have taken calculator. Now it hits you in the head. So if you, so simply, right, TI-83, and you type into the matrix, and you click solve, and you get what A, B, C, D are. And it's very simple, right? Let's take a look at other things. Sometimes stuff is hidden, right? Let's say we have to set up blah over x minus 3, x squared minus 4. What do we have there? Well, we have x squared minus 4. You can factor that. You better see it. that's not irreducible quadratic, right? If it's a plus, then it's irreducible, right? But with a minus, that's just x minus 2, x plus 2. So, a over x minus 3 plus b over x minus 2 plus c over x plus 2. Now, and I will link these two problems, blah over x minus 3, x squared plus 4. Now, x squared plus 4 you cannot factor over real numbers. And if you cannot factor that over real numbers, well, then you have to use the quadratic one. And the quadratic one is a over x minus 3 plus bx plus c over x squared plus 4. That's the setup. Procedure is always the same. Over here, find the common denominator, cross multiply, and then equal the top equals top. So that the procedure to solve these problems is always the same. The setup is what you must learn. So you have to memorize those four, and then you have to look at your denominator and decide what is given. So as you can see, I have three variables again. So at the end, it will be a 3 by 3 system. You will have equation for x squares, equation for x's, and equation for this. So I would like to do, one of these from homework. Again, just the partial fraction, and then when you guys are so on Monday, your next class, you guys should do the second part of this lecture, where you actually do this with integrals, right? So you will do the partial fraction decomposition, what you're learning tonight, on the side. And then when you have the partial fraction, you import that into integral. And then it's either ln's or u sub or inverse tangent, right? Depending on what you get. What do you think you're going to get with divided by x squared plus 4? Right? What is the derivative of inverse tangent? It's 1 over 1 plus x to the 4, x squared, right? Yeah. So the integral of 1 over 1 plus x to the x squared is going to be inverse tangent of x. So now you have to review that. So maybe you want to write that down as you are reviewing over the weekend. ln integration, and then inverse tangent integration, and then u substitution. Those are the endings that you can get from these guys. Maybe I should just drop over here that if you don't know the inverse tangent thing, and you say, oh yeah, x squared plus 4, I can do trig sub. Yes, you can. You're just going to get inverse tangent, which you could have just written out because you knew it, right? So inverse tangent is a basic integral. You have to know that one, right? Or it's going to be another 30 minutes to crank just for that one piece to crank trig sub. So good luck. And welcome to the 1%, okay? Now you're at 1%, so there's no games anymore, right? You're sitting in Calc 1. Oh, Calc 2, sorry. That's 1% of students here sit in Calc 2, so welcome to the 1%, right? It feels good. You got to deal with that. There's never free lunch. I mean, what can I do? All right, one homework example for this, and let's disappear into the night. Sounds good? Nice. Here's the wonderful example that I have no clue how to do right now. So let's go and see what happens when we factor dx over. Oh, no integrals. So I'm just going to do the partial fraction decomposition. I forgot. 1 over x cubed minus 2x squared minus 4x plus 8. Okay. Let's do some factoring from some algebra over here. I guess group the first two, kick out x squared, and we are left with x minus 2. Group out the second two, kick out negative 4, and you are left with x minus 2. Nice. Yeah, review factoring, as you can see. And now, 1 over factor out x minus 2 to get x squared minus 4. Whew, x squared minus 4 factors, right? But then you have x minus 2, so that's going to be squared. So it's repeated again. So we have x minus 2, and then another x minus 2, and then x plus 2. So the final version is x minus 2 squared, x plus 2. Wow, all that work just to factor. By the way, this had the integral and then dx. So there's some work to be done there later. Now we have this. So I'm supposed to do partial fraction decomposition. Okay, let's take care of that. So we have x minus 2 squared x plus 2 is equal to, I have a repeated linear. That's going to be a over x minus 2 plus b over x minus 2 squared plus c over x plus 2. Now we have to add these three, and then we will compare the numerators. Okay, usually when I teach algebra, I say to students, to add these, let's play the game of what's missing, okay? So you have the common denominator here. So what do you need to multiply into each of these to get to the common denominator? That's why I call it the game of what's missing. When you're looking at the first one, clearly what's missing is x minus 2, x plus 2. Right? So x minus 2, x plus 2 goes up there. Then you have x plus 2 missing on this one. That's the only thing that it's missing, because you have both of those. And on the last one you have x minus 2 squared. So now you just have to multiply these and add like terms. And you can immediately forget about denominator, because denominator on the left side and denominator on the right side will be the same. So you can start this equation as 1 is equal to, and just work this out. So x minus 2, x plus 2, that's x squared minus 4. So we have a x squared minus 4a. I should actually add that. So this is x squared minus 4, this is x plus 2, and this is going to be x squared minus 4x plus 4 as we go on. So plus bx plus 2b, or not 2b, and then plus cx squared minus 4cx plus 4c. Do I have x squared term on the left-hand side? Right? It's a 0x squared, right? So over here there is a 0x squared plus 0x and then plus this one on the bottom. So what do I have? I have a 0x squared is equal to ax squared plus cx squared. I have 0x is equal to bx minus 4cx. And I have 1 is equal to negative 4a plus 2b plus 4c. Cancel all x squares, cancel all x's, right? They can't be zeros, it's okay to divide. And because for 0, if there are zeros, it's a trivial solution, right? If x is equal to 0, you have 0 equals 0. 0 is the solution, so forget about it. Just get these. So what are my three equations? A plus c is equal to 0. B minus 4c is equal to 0. And negative 4a plus 2b plus 4c is equal to 1. So now you have to solve this. As I said, whatever witchcraft you know, do it. Right? Elimination, substitution, matrix. Obviously, if you're doing homework, right? But guys, you don't want to do too much of the calculator and thing because you don't have access to it on the test. If you're slow, right? When you practice, right? You don't get fast, right? So you become slow solving these. And you're not going to have enough time on a test. So you actually have to do them by hand every time during the homework to get faster, right? So when you will see, because on your exam, you are going to see 2 variables or 3 variables. I mean, you shouldn't be really going into the 4 and 5. When I give the test, it's either 2 variables or easy 3 variables, because you can have a diabolical one with 3 variables. And then I have a separate problem that could have 6 or 7 variables, but that's just the setup. So I say to students, just set up, do not solve, right? In the test it says do not solve. And then your job is just to go and set it up, because I want to see that you know how to do this procedure, to decompose. And you would have 7 of these variables there, but you don't have to solve it. So technically, it's just a one-line problem for 5 points or so, because it's just a quick thing to test if you know all 4 rules. Now to solve this, we can multiply the top equation by 4 to kill a between the first and the third equation, because second equation has no a already. So if I do that, I'll have 4a plus 4c is equal to 0, and negative 4a plus 2b plus 4c is equal to 1. When I add these two equations, I get 2b plus 8c is equal to 1. So now I have b minus 4c equals 0. That's equation number 2 that we did not use. I want to label all the equations. This is a new equation. I'll call it number 4. So here's number 4. And now you reduce the 3 by 3 into 2 by 2. Times 2 on the top. We have 2b minus 8c equals to 0. 2b plus 8c equals to 1. When you add these, c's die, and you have 4b equals 1, b equals 1 over 4, and immediately you can go back, find c, go back, find a. So I have equation number 2 now. B is 1/4 minus 4c equals to 0. 4c is equal to 1/4. C is equal to 1 over 16. And then A is opposite of C. So from equation 1, A plus C is equal to 0, which means A is negative C is equal to negative 1 over 16. There is no need to circle these because that's not your answer. Those are just A and B. There is integration to be done, right, for this problem. So this much, what we did, is your pre-calculus lecture 7.3 or 7.4 in the pre-calculus book. These books are available in the tutoring center and the library on the reference, so you can go and you can take a look at those at those lectures, and read them, and then practice a little bit more, because over here is just calculus, right? They don't talk about this stuff too much. I have ABC, so go back. A is over x minus 2, so that is negative 1 over 16 over x minus 2, plus B, which is 1/4 over what? X minus 2 squared. Oh, come on. X minus 2 squared, plus C is 1 over 16. It's important to put them in the right spot too, so that you have to, I mean, OCD is amazing if you have it for these things. I mean, and there you go. Now integration is a joke, right? We have basic ln with 1 over 16 in front of ln. We have another basic ln at the end with 1 over 16 in front. We have u sub over here, right? X minus 2 is u. You get 1 over u squared, keep 1/4 outside, basic u sub. So ln, u sub, ln. Again, that's Monday, not today. Done. See you around, maybe. Bye.